Should we start?
Yeah, I think so. Uh,
Yeah, we should.
sure. So, shall I just kick off the proceedings, Dr. Vinay? Is it okay?
Yes.
Yeah, sure.
Yes. Yes.
Yes,
Yes.
sure. Sure. So good evening, everybody. I'm Dr. Senthil Velan, and we have Dr. Vinay today. He's the associate professor in Tapa University of Engineering and Technology. Yeah, it's located in Patiala. He's a specialist in image processing, and his team mainly focuses on natural language processing and also computer vision learning. And he's done a number of research papers relevant to the particular fields, and in fact, he also holds a number of patents relevant to image processing and also the character recognition, automatic character recognition. So that's the brief introduction to him. But how we came about doing these series of talks is that this will act as a forum for both engineers as well as doctors to actually come together. Because in India, what happens is that the ecosystem does not allow us for frequent interactions between the doctors and the engineers. What happens is that the engineering is a separate stream, and the doctors, they have their own separate stream, and then getting them together is always a task, and it only happens when you actually have a big project and then you recruit them together. But this whole ecosystem, what we wanted to actually bring about is that you can freely talk to each other on this series of talks, and subsequently we can have discussions so that there is free flow of ideas, so that we can actually look upon as a solution based problem, so that we understand engineers and engineers understand doctors. So I welcome Dr. Vinay. So, and please go ahead, Dr. Vinay. Thank you.
Uh, Thank you, Dr. Senthil. So, as you said, we are a forum for doctors and engineers, and we will keep on meeting in future as well. But we to kickstart this forum and to have interactions initiated, we thought that we should go ahead. My name is Vinay Kumar, and me and Dr. Rahul, we work in this AI and biomedical imaging research lab at Thapar Institute of Engineering and Technology. When we think of images, the regular images, we think of something like this. People, some of them are, look beautiful. Some of them look ugly to us. Uh, and generally, these are the pictures which we process as far as the people are concerned. There are scenes, etc. also, but we will look at only people. But when doctor looks at the images, especially the medical images, they are something like this. And in these images, all of us look almost the same. And that makes the task of a doctor very difficult, because he's or she is looking at something which generally people don't understand. And at the same time, these very complex structures, which we see over here, uh, give information which is not very easy for us as engineers to interpret and understand. But at the same time, engineers are there to help doctors to make sure that these specific images are capable of delivering the message, or the doctors are able to visualize and make decisions to carry on the procedures which they have to do. So before we look at these images and try to understand what happens, let us look at a small video, which will, because in this meeting we have number of engineering background students as well, and the faculty, academicians, researchers too. So let us have a quick look, a minute-long video, which will tell us what X-ray and CT scans are, and how CT scan is more or less related with X-ray. I hope you are able to listen to the audio as well. Anyone?
There's no audio.
Audio,
Sound was not
Audio-
there. Yes, audio was not there.
Oh, okay.
Share.
How do we do it? Same as system, I
Sir,
think.
on Zoom, you will get it. When you share the screen, you have to share the audio also.
Now, is it? Can you hear the audio now?
No, sir, it's not there.
Maybe you can explain it all along if you. That's
All right. Okay. Yes, that will be better. So CT scan is an X-ray process where we have, two-dimensional images. These CT images are more detailed than when we look at the X-ray images. They are capable of, differentiating between bones. So this is a regular X-ray which moves in single direction. Whereas in CT scan, we have these X-rays which rotate around the body. And here is the receiver which receives these. And this detector picks all the X-ray. And so these X-rays are capable of generating one-dimensional image, or these are two-dimensional images. And at the same time, if we connect these two-dimensional images, the CT scanner is, with the help of a computer, is also capable of generating these 3D. Anyway, so this is what a CAT scan is. CAT scan or CT scan is nothing but a three-dimensional X-ray. So X-ray is the most important, one of the most important images which doctors look at to make certain decisions, be it a two-dimensional X-ray or three-dimensional CT scan, which is also called as computed tomography. If we look at this image, we can see that there are various colors which are present, and here is the one which tells us what is what. So light yellow color is the air, and then we have fat, water, liver, muscles, kidneys, bones, etc. So when a doctor looks at this CT scan, he or she will be able to understand what part of the body is holding air, which part of the body is holding fat, water, and so on and so forth. And on the basis of these, they can decide either those parts of the body are working perfectly or not. We will see in the coming slide how this all works and how engineers can help doctors to understand these complex images better than if we do not use image processing based techniques. When we say images, generally what doctors or what regular people see is this, or when we look at an image, we see something like this. But when a computer looks at these images, this is not exactly like that, but it is a set of numbers or an array of numbers. And for three-dimensional images, these array of numbers are in 3 dimensions. If the image is two-dimensional, like a regular photograph, which we click with the help of our camera, etc., they are two-dimensional, which means that only one set of this array is available to us. Now, since the computer is going to look at only numbers, therefore it becomes quite challenging for engineers to develop algorithms which correspond to visualizations in these regular two-dimensional or three-dimensional images. So what should we do? It indicates that when the computer programmers or engineers try to develop an algorithm with the help of these numbers only, they should be in contact touch with the medical practitioners so that they can take correct decisions. And on the basis of those decisions, they can develop new algorithms. medical imaging is a very fascinating area. And since it is very fascinating, the challenges are also incredible. And at the same time, when we develop some algorithms for medical professionals, we get a good rewards also. Uh, what we are, what type of rewards we get? We are trying to help humanity to become better, more healthy, and so on and so forth. Medical imaging is very different from other image processing algorithms, which generally people study when they do their engineering or maybe masters, etc., unless and until they're working specifically in medical imaging areas. One of the major differences is that generally when we start investigating, we start working with medical imaging problems which are presented to us. For example, if you look at this image over here, there's a lesion on the skin, and doctor comes to us and he asks that, can you help me in finding out what type of segment it is and how it is different from others? And over the period of time, he would also like to track the characteristics of this particular part, maybe after a month or a year or something. And then on the basis of the changes which he or she is going to look at this region, he or the doctor is going to take corrective actions and maybe give medicine or do some other surgery, etc. This is the problem which the doctor faces. And when he comes and asks the engineers, they have to, first of all, identify only this region on the skin, which is different from other parts of the skin. And this problem, which is called as image segmentation, is a difficult one, right? Once we are able to identify this particular region, it becomes extremely difficult again to make sure that over the period of time when the shape, size, etc. of this changes, we are able to track these changes. Although it seems for human beings to have a look and then decide whether it is increasing or decreasing. At the same time, whereas if we use computers, the small changes in these regions becomes very complex algorithms. If you look at other images, for example, these images, these are the images of lungs. If we use lung reconstruction based specific algorithms, then from here, if we compare these two pictures, for example, this is a better image than this for a doctor, and this is a better image than this. For the simple reason that the radiologist will be able to take better decisions by looking at this image, since many of the portions which are not available over here are available for visual inspection in this image. And same happens over here too. Now, CT scans and X-rays are all based on the technique which is called as X-ray absorption. Before we move ahead, let us look at some terminologies. X-ray absorption by the body is measured by something which is called as Hounsfield scale. This Hounsfield scale is an absolute scale, which means that air intensity is, in this case, is fixed for Hounsfield scale, which means that air intensity is fixed from -1000 to 0 intensity for the water. And this is the absolute scale, which means that it is not like other images. So if we look at the basics of image processing, what happens that generally images are captured on a scale of 8-bit. 8-bit indicates that every pixel, the pixel means that, for example, this image is divided into small portions, as we looked at in the previous picture. And each of these small portions, which is part of an array, it contains some value number n, right? And if we look at regular images, this n is nothing but 8-bit number. 8-bit number indicates that this value n can be anything between 0 and 255. So since computers are capable of storing values only in binary digits, Therefore, we have to convert them into binary digits. This 255 requires 8 binary bits to be represented as a binary number. A binary number is 1, which is represented by a combination of zeros and ones only. So generally, when we write algorithms for image processing, all of these numbers, all of these small parts of the image, which are in an array, they are made up of these small values, which lie between 0 and 255. What is the advantage of having values between 0 and 255? It is very easy for us to represent them on a computer screen, which means that if we want to visualize something and the values are ranging from 0 to 255, we have a small screen, we will be able to distinguish what lies where. Whereas if we look at this Hounsfield scale, the intensity the intensity variation is very large, and therefore the visualization libraries which we have, it becomes very difficult for them to visualize things from minus 1000 to 1000 plus. So what challenge we have for the engineers, that we have to make arrangements, or we have to make sure that we are capable of re-representing these values which are lying between minus 1000 to 1000 in such a way that these values are lying between 0 and 255. To do this, what we do is, or what engineers or the programmers do, they limit their attention to different parts of this range and focus on the underlying tissues. Now, if you look at this, we can see that the lung area lies over here, fats are over here in this range, soft tissues lie within this range, bone area lies within this range, and so on and so forth. So while we are developing an algorithm, we have to make sure, if the doctor has to take a decision by looking at the lung area only, then that the window size we can reduce to the area which is around lung, so that the images looks better than what they were in the if we have looked at all the grayscale values. If we look at this, it seems that this is not a very good idea, for the simple reason that if we are extracting only a part of these grayscale values, then there is a possibility that at the end of the day, when we execute our algorithm, we might not be able to extract, or we might not be able to generate a good image. But that is not the case. If we look at this image over here, this is a CT scan image. This is the image which does not uses that W window size methodology to improve the quality of the picture. Whereas if we develop an algorithm which are specifically made for lungs, for example, in that case, you can see that if we compare these two images, the second image looks much better to take some decisions by the radiologist or a doctor. If we move our window to within the tissue areas, then this image, which comes from this image only, right? So this image is once we run an algorithm and extract or utilize that small window to extract values which lie for the lungs, we will get this image. And from this image only, if we use W, which is the window area, we'll get an image which is something like this. So our doctors will be able to make decisions better by looking at this picture rather than looking at this picture, because over here we have extracted tissues, and the information content which is represented over here is much better than if we look at this image. So when we write algorithms as an engineer, it is extremely important for all of us to work together and make sure that the information content which the doctors have to look at before making any decisions is correct or not. So thresholding and deciding about the window size, etc., it becomes extremely easy for us, for the engineers, to develop algorithms if we know what type of information we are trying to extract. Imaging and its analysis is extremely important. One of the things which we need is that while we do analysis, we must be able to understand the images. We must be able to visualize images. And at the same time, we must also be able to quantify the information. What does it mean? It indicates that understanding the images indicates that, based on the type of decision which we are trying to make, we must be able to reach the correct client and find out what type of images or the results he or she wants. Visualizing are the tools which are required for non-technical people so that they can take correct decisions quickly. And quantifying information indicates that when we say that, yes, this image is giving us enough information, whether it is true or not can be found out only by deciding and extracting and measuring the information which is required by many of people. So medical images, are different from other pictures. They depict the distribution of various physical measures from the human body or maybe animal body. And analysis of medical images has specific expectations. For example, doctors would like to automatically detect the tumors, characterize their types, measure abnormal structure, visualize anatomy to decide whether a surgery should take place or not, and exploring the relationship between image-based markers and the clinical things. By making these decisions, they will also be able to decide whether it is required that body be cut open, which means that a surgery should take place or not, or we can use some other technologically advanced ways which might be less invasive or completely non-invasive. And we means the doctors can also see molecular activities which are not visible to naked eye. And on the basis of these things, they can make decisions better, possibly better than what we do without using the technical advancements. Medical images pose a lot of challenges. Some of them these are multidimensional images. For example, 2D is a X-ray image, 3D is a CT scan, and there are going to be other images also which are more than 3-dimensional. They have a large dynamic range. When we say that they have a large dynamic range, it means that the values which corresponds to lower color, for example, black to white, in regular images, they are between 0 and 255, but some of the tissues or different areas of bones are so close to each other that we need more and more number of pixels, which means we need more and more number of gray scales to differentiate between two types of issues. They are produced on different imaging modalities in hospitals and make high demand upon the software for visualization and human computer interaction, since the doctors have to take decisions in real time. Therefore, whenever there is high demand on the complexities, taking decisions and making, for example, technical visualization-based assistive surgeries, where you have to take decisions in real time. And if the model is very complex, there is a very high possibility that the doctor will not be able to take the decisions as and when they are required. So other than that, medical images, why it is so complex? Because medical images, since they have a high dynamic range, and there are multiple images which are required to take a decision, the size of the image becomes very large. High resolution MRI image is of around 100 MB. In clinical studies that involve analysis of time sequences, etc., they can easily exceed 10 GB, which means that while we design and develop these type of pictures, it becomes extremely difficult for us. So a high resolution MR image, which contains 200 slices of 512 and 512 pixels, which means that more than 50 million voxels. Voxel is a pixel with a volume, which is like a three-dimensional image. A pixel defines a point in 2 dimensions. So in 3D, it becomes extremely difficult for the software which is involved in giving the visualization assistance to the doctor. It becomes extremely difficult for it to make the visualization in real time possible for the doctors to look at and go ahead. Medical image analysis can be performed in 2 ways. One is manual, which requires a lot of time and training. And then we have automatic image analysis tools, which requires computing resources. They are very good, but given that, it's very, first of all, it's mathematically very complex. And second, the size is extremely large. Therefore, it becomes sometimes very, very difficult for us to use tools to perform all the tasks, whichever are necessary. There are 3 major areas in which medical image processing, we can look at medical image processing. One is the regular image processing tasks. They are generally utilized to improve the quality of the image. Once we have improved quality images, we can utilize those images for taking the first-hand decisions by the doctors. And then we have machine learning algorithms, since it becomes extremely difficult for regular mathematics-based image processing algorithms to improve the quality of images. Wherever the grayscale values are very close to each other, it becomes even more difficult for us to take a decision on or differentiate between 2 types of tissues, 2 types of grayscales. And in these circumstances, generally people use machine learning based algorithms. Machine learning based algorithms are capable of differentiating even a very small change in the grayscale. Although we can do it with mathematics also, but the mathematical algorithms are more complex, and therefore they take much more amount of time to perform the same task. Whereas if we have a trained network, neural network, or machine learning network, then that trained network can perform the same task much more easily and quickly. Then we come to image understanding. We know from regular images, for example, driverless cars, they also use image understanding, where the camera which we use on driverless cars, they identify objects, and based on that decision, they take what type of object it is. They take the decision in which direction or to move or to brake, etc., and so on and so forth. Same happens with the medical images also. There are semantic descriptions and content understanding. These are extremely important, especially in the cases where we would like to perform automatic procedures on the patient. The camera, which is going to be linked to these small devices, which can perform small surgeries or or can take some other decisions all by themselves, they must be able to get the semantic description and must be able to understand the content and then take the decisions, whatever it is. Once this is done, another important part is the image enhancement. So medical images are generally deteriorated by noise due to various sources of interference, especially if we look at procedures. I have looked at only at YouTube, so I don't know. But if you look at the surgeries, we can easily see that it becomes very, very difficult for people to understand what is the part of which area is going to be operated upon, and which are the areas which one is not supposed to touch at all. And we know noise is something which is not required. So medical images, since they they come from a very, very complex environment. So most of the things may be noise while we are trying to take a decision. Improvement in appearance and visual quality of the images may assist in interpretation of medical images. And enhancement algorithms are developed for deriving images that are meant for use subsequent algorithms, and so on and so forth. So the point is that, once we have an image, it becomes extremely important for us to make sure that the images which move to the next stage, whether we are going to use automatic process or procedure to take decisions, or we are going to help doctors to look at those images and then take decisions. So image enhancement becomes extremely important for all of us. And there are multiple things which happens in image processing, but image enhancement is one of the most important ones as far as the medical images are concerned. Now is the time of artificial intelligence. So AI is generally very useful while identifying the patterns. Since these patterns, identification of these patterns is extremely difficult if we do it mathematically or with the help of statistical methodologies. So AI is of great help when we come to medical imaging. It can offer unique opportunities for learning about fine imaging changes reflective of poorly understood disease processes, and so on and so forth. We know that nowadays AI is applied in many, many medical processes. Even if I'm not wrong, I think the AI helped quite a lot in developing the vaccine for COVID-19. So this is it. Thank you very much for listening to me so patiently. I think we can now start maybe some questions if somebody has a question or somebody would like to say something.
So, thank you very much. So before taking the questions, I just need to inform all our participants that very soon we will be uploading this video onto the YouTube. So we have created one YouTube channel, and once the video has been uploaded on the YouTube, we will be also sharing the video link with all our participants. Also, the other people who have registered and not joined, we will be sharing this video with all of them. So now with this, I think we can take the questions.
Okay. So first, shall I? I have Dr. Sendhil Velan here. So first of all, Dr. Vinay, can you hear us? I mean,
Yes, I can.
yeah. Sure. Yeah, excellent talk. I mean, there's one saying, no, you can't make it, keep it simple, but not more simpler. I think, it really was to the point, and I really appreciate your efforts in trying to make a complex subject simple. So first of all, thank you for that.
Thank you, sir.
But I have two questions. One is that we always, as doctors, we come across a lot of articles, and even in our medical kind of literature where we generally talk only about surgery. Now there is quite a few articles that comes up as use of artificial intelligence, and not artificial intelligence, use of machine learning algorithms in identifying these pathologies. To quote a few examples, let's say if there is shoulder arthritis, and to compare different CT scans and how to plan for them, and how to differentiate different grades of arthritis, to just give you an example of an article. But there is still a lot of skepticism amongst medical colleagues. So it is obviously because we are trusting machine learning algorithms. So my first question is, how reliable are these machine learning algorithms, and what factors would actually come to play in determining the accuracy of really saying this image is depicting this pathology?
Well, as far as the machine learning based algorithms are concerned, I'm pretty sure that we cannot rely 100% on them. That is why we need doctors, we need practitioners who they are only to help us. As we looked at few of the slides, that the machine learning algorithms are capable of generating better quality images, in the sense that they will be able to remove whatever is not required. But when we say whatever is not required, since most of the time they are the engineers which take that decision, maybe without consulting the doctors, or might be they are consulting the doctors also. So when we say that we have to remove some unwanted information, there is a very high possibility that these machine learning based algorithms may remove something which is important for taking a decision. This is one. Second is that machine learning algorithms always come with something which is called as the accuracy. So if we say that, the machine learning algorithm is capable of giving an accuracy of say 99%, but in general, what happens that the images which are provided to these machine learning algorithms are controlled images, which means that there is a possibility that all possible variations which can happen in human body are not passed to the machine learning algorithm. And therefore, their learning is always narrower than what a doctor knows, because all of the pictures are not captured and all of the pictures are not utilized in training the machine learning algorithm. So when it comes down to relying on machine learning algorithms, we always have to take it with a pinch of salt. It is extremely important that they are utilized only as assistant to the doctor, so that the final decision is made by doctors. But if we look at few articles, I mean, I don't read core medical journals, but if we look at some of the magazine articles where these machine learning algorithms were quite helpful for doctors in identifying certain diseases even before their full-fledged onset. So in that sense, I think machine learning algorithms are quite helpful. But taking a decision only on the basis of what predictions or what recommendations machine learning algorithm is making might not be very safe, at least at this given moment of time. This is what I feel.
Thank you. Just one more
Yeah,
question,
yeah.
and I'll let others take the questions afterwards. So, a point rightly made. Right now, you are saying that the algorithm that is used for image processing and also for not just the processing, but actually to make predictions based on the images are still need a lot more refinement. That is one thing. But obviously, as time goes on and we actually get more and more images into the repository, and then obviously it's going to help. And definitely there's a lot of strides that's been made. For example, detecting retinitis pigmentosa, for example, in the eye. At a very early stage, because this retinal images that's being processed by AI in image processing, they detect it very early, and the treatment can be initiated very early. And like that, a lot of precancerous lesions in the skin, for example, melanomas, again, there's a lot of articles that has been shown that these precancerous lesions, if we can detect them early, maybe we'll be helped. So like that, not only radiological images, even clinical images and photographs, they are being used, and I'm sure as we make more strides, we'll have more collaboration between doctors and engineers through this forum and also otherwise, so that they can actually come to light and discuss with the engineers what can be done and what are the limitations, how can we actually collaborate. Thank you, Dr. Vinay.
Thank you, Dr. Senthil. Yes.
Yeah, Dr. Senthil, in your direction regarding the accuracy about this machine learning, see, one of the biggest challenge for the machine learning, the data set. Like what happens that that image data set, whatever the clinician they do not store this data in a very proper manner. So like what happens that like in the last few years, I had reviewed several papers, and most of the paper they are focused on the online data set. And because of the online data set, this data set are not reliable. So that's why this this machine learning, they have a limitation. So in this direction, there is a need that we have to bring because this machine learning, they are based on the training. So whatever the images are there, that should have a very like a clear information, and there should be a large data set. So that is one of the biggest challenge in for the machine learning people, that we do not get the actual experimental or the clinical data. So that's actually we are trying. So that's why we are trying that we can recently, because in last 1 year I had reviewed around 10 to 20 paper on the X-ray on the COVID. Everyone is using a similar kind of data set, and they are just making the different algorithm. So, but the problem is that whatever the online data set, this online data set has a limited reliability. So it is always good that we can focus directly on we need to collaborate directly with the clinician or the radiologist, So from where the data is generated, and we take the data directly from there, and all the interpretation need to be connected with the machine learning people. So that is actually required for better accuracy or for the to reach to the real need people.
Yes, sir, it's very rightly said. And here, like the forum like us, the forum for doctors and engineers is going to play some role, because see, in India, we have seen very less collaboration between doctors and engineers. That's why clinicians, they are doing their own job. Radiologists, they are doing their own job. They are recording, they are taking the images, they are keeping with them. They are doing the decision instantly, but they do not keep the data set to provide to some engineers or some AI person, so that they can run those data set on some AI model, and they can train it and then maybe validate that. So maybe for that, this collaboration or this forum for doctors and engineers, maybe we can help in this direction, and in a better way we can work together, and we can also get it trade. Maybe we can also tell radiologists what kind of images can help us to detect a certain type of a disease. So this kind of collaboration can be extended in that direction also.
Yeah, well said, Doctor. It's Dr. Rahul, isn't it? Yes.
Yeah.
So maybe in the next few sessions or something, maybe if you can give us maybe another talk on how to actually collect data in what format, and how to have clean data available. It could be a simple X-ray, not just chest X-ray. Let's say fracture X-rays. There we have endoscopic images, we have arthroscopic images. And we always store them, but how to store them? Is there a storable format? Do we, in fact, we know is that, as you said, these images are very kind of like heavy in terms of storage space. So so maybe next time, if you can give us some practical examples of how to actually what do you call, bookkeep these data, how to actually present to the engineers in a format which is actually readable and analyzable. Obviously still there's a lot of work that you guys will be doing before the data is processed, but still it'll make things easier and also simpler in terms of collaboration.
Yes,
Sure,
that's
sir.
right. So there are some standard formats which generally medical imaging utilizes. One of them is, I believe it is called a SciComm. The point is that when these people who sell machines which are utilized to capture X-rays or CT scans, etc. Generally, what happens that it becomes maybe quite difficult for doctors to have uh, access to the raw information or the raw data, which can be easily transferred to a device, maybe external hard disk, etc., and then maybe it can be utilized. I have no idea. Yes, but I think it's an excellent idea, Dr. Senthil, that we should have a next talk, or maybe next to next talk, where we can talk about uh, collecting this data and keeping it in a format which can easily be accessed by the doctors and engineers or anybody else, data scientists, and so on and so forth. Any other question, anyone, or anything anyone would like to add?
Yeah. In this data, Dr. Senthil, is it possible that can you arrange 1 or 2 talks with the radiologist who can give some information, because we know little bit about these images. So is it possible that we can have some talk from the radiologist, or maybe the people who are really, the doctor who are really interpreting this data, and they can tell us that in which format they are first storing the data. So that will be really helpful for us, and then we can interpret.
Yeah, definitely, Doctor. So I think we can get radiologists in the forum. Yeah, I'm sure they'll be interested, and it will be helpful. In fact, as you said, they can, kind of talk in a simplistic term. That's the challenge. So that how actually they store the image, how do they interpret it, and also where is it stored, and there is obviously the data protection that comes into play, because especially when you're dealing with patients data. But obviously there are, as long as we stick to the rules, still science has to progress. So as long as we actually have the way of how to actually access these images with adequate following the rules, I'm sure it can be done, and that can be arranged, Doctor, not a problem.
See, for the data protection, whenever we have to work with the clinical data, we have to go to the ethical approval. So whatever the ethical committee will be, either from Thapar or from your institute, we have to pass through, because without that we cannot use any data. So
So we can also, sir, one talk on data protection and management. There
Yeah.
are these policies and regulations are already available.
I think we
So
can decide this
we can
later as
talk about
well.
it. Yes.
Yeah.
Yes.
Yeah.
Anyone
And
else
we can
who
decide
has,
also later.
anybody else who would like to add to whatever discussion we are having, or maybe have a query or say something else?
Yes, I think time is also approaching now.
Yeah,
Yes.
that's right. So anyway, I hope that this talk was helpful, or maybe not. I am not sure. But yes, as we move on and we are going to have more such talks, etc. There is a very high possibility that all of us will benefit from these talks, and we will be able to explore more possibilities of collaborative research, working together, understanding more and learning slightly more than what we know as of now.
Okay, on
If
that
nobody
note,
has, yeah.
just to interrupt, sorry,
No,
if you
please.
can actually also kind of like tell everybody in whoever is the participants, how do they actually contact, the engineers who are involved? For example, you have given the talk on image processing. So if a doctor
Right.
wants to connect to you, how does he actually, connect to you personally, or how does he write to you, or just to pick up the phone and speak to you? How does he actually get his idea through? Please elaborate.
Well, thank you, Dr. Senthil. I think I completely forgot to mention my email address or how to reach to me. That was very, very important. So, what we will do, when we send this email, a link of YouTube video, we are also going to send the email address of mine. And anyone, whoever is interested, they can send me an email, and I'll revert back as soon as possible. I think this
And
must
also, sir,
had been a
what we
part
will
of
do-
my presentation, but it wasn't. So sorry for that. But yes, I can, as of now, in the chat, I can maybe write here for in the meeting.
And also, sir, we will upload our details on the website. So we do have web page.
So
On one
I
section
have-
of the web page, we'll upload
Yes.
that.
That's right. That's right. So we have an email which is available on our website. We'll send you the link to website also. I have also shared my email address. Thank you. And next time onwards, we'll make sure that it is part of the presentation, so that whoever would like to interact with us, they can quickly reach to us. Aviral Charia has also shared the link to our website, so you can visit that too.
Thank you very much, sir.
Thank you very
Thank
much.
you.
Thank you very much. Thank you.
Thank you, everyone. Thank you. Goodbye, and we'll meet again. Thank you.
Okay. Bye-bye.
Bye.